Good morning, my dear students. So, in the previous clip, you have been started learning about the steps in the process of rDNA technology. So, as you have been learned, the process of recombinant DNA technology consists of 6 steps. In that, the first step is isolation of a genetic material. You come to know that isolation is nothing but separation of the desired gene by using three different enzymes like lysozyme, cellulase, and chitinase. So these different for the bacterial cell, plant cell, and fungal cell respectively. And along with that, you have been learned by addition of chilled ethanol, we have to take the fragments of these DNA. That was the first step of isolation of a genetic material, that is the DNA. For the second one is cutting of DNA at a specific site by using restriction endonuclease enzymes. So specific site is nothing but you know very well that is of palindromic sequences. You learned these all the things in the previous class itself. And the third step is the amplification of a gene of interest by using PCR. So these three steps like isolation of a genetic material, cutting of a DNA at specific location, amplification of a gene of interest using a PCR, that is a polymerase chain reaction, and amplification is nothing but making the multiple copies of the desired gene by polymerase chain reaction is called as amplification. So up to this you have been studied in the previous clip. Today you are going to be learning the rest of other. The fourth step, that is insertion of rDNA into the host cell or organism. So as you know, insertion means to introduce, ಒಳಗಡೆ ಹಾಕೋದು ಏನನ್ನ rDNA ಅಂದ್ರೆ ಸಿಕ್ಕಿರುವಂತಹ ನಮಗೆ ಬೇಕಾಗಿರುವಂತಹ ಡಿಸೈರ್ಡ್ ಜೀನ್ ಅನ್ನ ವೆಕ್ಟರ್ ಮೇಲೆ ಹೇಗೆ ಹಾಕೋದು ಅಂತ ಕಲ್ತಿದ್ದೀರಾ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ as rDNA ಟೆಕ್ನಾಲಜಿ. ಆ ವೆಕ್ಟರ್ ಅನ್ನ ಹೋಸ್ಟ್ ಸೆಲ್ ಒಳಗಡೆ ಹಾಕಿ ಮಲ್ಟಿಪಲ್ ಕಾಪೀಸ್ ಅನ್ನ ಬೆಳೆಸಬೇಕು. ಅವಾಗ ಆ ಹೋಸ್ಟ್ ಸೆಲ್ ದಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ. That is the main theme of this. The product may be a protein, hormone, enzyme, whatever that may be used for a medicine or something else. So that is the rDNA technology main theme of it. So here, insertion of rDNA into the host cell. In your previous periods or previous clips, you have been studied one clip that the insertion of rDNA is taking place in a sequential, like heat transfer method, gene gun method, biolistic method, like such. Through that, this insertion of rDNA will take place into the host cell. Either it may be by heat treatment method. You know very well heat treatment method, approximately 42 degrees Celsius to that divalent of calcium is going to be using. Divalent, 2 calcium ions. So divalent, calcium divalent is going to be used in the medium when the boiling at 42 degrees Celsius. That is a heat treatment method for insertion of rDNA. You have been studied in one clip, right? And there also the another two, gene gun method or biolistic. You know very well that gene gun method, direct introduction, injecting itself, and biolistic, you know very well, that is also the one. There you are going to be using the gold and tungsten as in high velocity particles, wrapping the DNA on these particles, that you have been learned. That is the insertion of rDNA into the host cell. So after inserting that rDNA into the host cell, so consider here, right? We will go for consider this is a petri dish, this is a host cell, and in this host cell these are the recombinant vectors. Now these recombinants should take entry into the host cell. It may take 1 or 2, it's immaterial, number of copies they can, because one the bacterial cell can consist of 10 to 15 copies of a plasmid. That is very important point to be remembered by the student, right? So these plasmid, you know very well plasmids are nothing but extra chromosomal DNA present in the bacterial cell. and these plasmids are acting as a vector, and a vector is nothing but gene taxi. Gene taxi is nothing but carrier of the desired gene into the host cell. So these are the steps or the point that the student should remember, right? So that is how the insertion of RNA will take place into the host cell or organism in this way. So during this, some of the host cell will not take this RNA. So they are going to be separating the host cell which have taken the rDNA and the host cell which do not taken the rDNA should separate, because the host cell which do not taken the rDNA will not produce any product, so they are waste. So we want to kill them. How to kill them? Very simple. These hosts are going to be keeping them on agar medium. Agar, you know very well, agarose, and that agar medium which consists of either ampicillin or tetracycline. And ampicillin, tetracycline, kanamycin, chloramphenicol, these are the antibiotics which are called as a selectable marker. Most important question for 1 mark. Already in your tools you have been studied selectable markers. See, imagine that this is the vector and this vector consists of two. One is ampicillin resistant site and another one is tetracycline resistant site. You know very well that if you remove the tetracycline site and the desired gene is introduced, the tetracycline resistant site will be lost by this vector. And if this is grown on ampicillin, automatically this vector will leave because it has lost tetracycline. So now such things, such a selectable ampicillin is using here as a selectable marker. When you will going to be adding ampicillin to it, the rest of bacteria which do not carrying the vector will die, because they do not contain an ampicillin resistant site. Understand? So this is how selectable markers are going to be used. That is the 4th step. Then 5th step is obtaining a foreign gene product. Now the host cell containing the vector, this vector containing the desired gene. Now this host cell should be cultured, 1 cell to 2 cell, 2 cell to 4, 4 to 8. Means that much number of genes will multiply, that much amount of a product will come through the help of a step called as obtaining a foreign gene product. So obtaining a foreign gene product is taking place by a huge tanker called as a bioreactor. Most important question for a 3 mark or a 5 mark will ask you for your final examination. So bioreactor are of two types. This is simple stirred tank bioreactor and this is sparged tank bioreactor. They may ask your final examination for 2 mark or 3 mark. Draw a neat level diagram of a stirred tank bioreactor, sparged tank bioreactor. 3 mark questions. So 5 mark questions, write a note on bioreactor. So these are the steps how they were going to be taking place in it. So stirred tank bioreactor, in this we are going to be adding a culture medium. So the culture medium is going to be adding along with this host cell, and this stirred tank bioreactor containing foam breaker and it containing a culture broth. Culture broth is nothing but the sugar containing a material itself. Then sterile air for here sterile air is going to be adding the oxygen because for the growth of the bacteria. Then here acid base pH controller will be there, acid base controller, and here steam is going to be passed. Through this steam is passed for sterility. So this is the stirred tank bioreactor. In this, it is going to be repelling, means clockwise direction they will transfer. Like this, in your mixer grinder, how the blade will be there, that is called as a compiler. And these compiler rotate the stirrer, and that brings the friction. From the friction, the bacteria will get the heat. From that heat, they will start eating the food material present in this culture broth, and they will become a duplicate. Because bacteria hardly take 30 minutes or 20 minutes to become duplicate. You have been studied in your first PUC, at the same time in a molecular basis of inheritance. Right? So in that way, they will getting the product, that is obtaining, taking, yielding a foreign gene product by the help of a stirred tank bioreactor, or this is a sparged tank. In this sparged tank, only this is going to become rotate. This will go for rotate only. This like this only. This is a stagnant, and this will rotate in this manner in the clockwise direction, and automatically the foam beaker will be there, the gas entertainment will be there, oxygen material is going to be adding in it for the growth and the development of the bacteria. So this is how the foreign gene product is going to be taking place. Foreign gene product can be extracted from this. Foreign gene product is going to be extracting by the help of either stirred tank bioreactor or sparged tank bioreactor. So these are the two important things which we are going to be using on this. So during this process of